Netcat is a useful utility that comes installed with a lot of Linux distributions. In Kali Linux, Netcat Traditional is installed. In more recent versions of Ubuntu, you may find that Netcat BSD version is installed. There are some slight differences, and you can install either version on either system by uninstalling the existing version and reinstalling the version you want. On Kali Linux, we have Netcat Traditional, and then I've also have an Ubuntu machine where I've uninstalled the default version and installed the same Netcat Traditional that comes with Kali, so the two versions match. You don't need the versions to match to use them with one another. So one thing we can do is we can set up a simple relay between the two computers. Netcat will serve connections over TCP or UDP. In our case, we'll just use TCP. So to start with, we'll set up a listener, -L, which means that Ubuntu will listen for a connection from another computer. We'll give it a port to listen on, 99 in this case. On Kali, we would reach out to that computer using its IP address. In this case, that Ubuntu machine is at 137, and we need to use port 99 because when we set up the listener, we picked port 99 over on Ubuntu. So now the two are connected with the TCP session. For example, if I type hello on Kali, we see that displayed in Ubuntu. And if I type hello Kali back in Ubuntu, we see it displayed over on Kali. So this is already shaping up to be a good way to get information from one machine over to the other machine when perhaps there's no default program or no default communications between the two machines. If we take this a bit further, we can transfer arbitrary data that's in a file. So over here on Ubuntu, we'll just go ahead and create a file. We'll set up the same Netcat listener we had before, but this time we'll just redirect the file. So when the listener sets up, it's going to listen for connections on port 99. Whenever a connection is made, this listener is waiting to push this file over the wire to the machine that connects. So if we connect without writing the contents out to a file, it should just display the contents to the screen. Because by default, Netcat always sends the data that's incoming from the other machine to standard output on the current machine. And notice the two are still connected together. But we can't send any more data from Ubuntu back over to Kali. You can end the session by Control-C. And whenever you end the session on the other side, the other side will automatically terminate. It's a TCP session. Not only can you send files back and forth, which in Excel is extremely useful, but you can also send shells back and forth. So for example, we could set up our listener again, but this time what we'll serve over the connection will be bin bash, which is the regular standard shell in a lot of Linuxes. So the server is set up, and then over on our client side, which in this case continues to be Kali, we need to connect. And now when we connect, we're not connected over a simple TCP socket, the connection is sending data back and forth from Kali to the shell running on Ubuntu, and then when the shell responds, that's coming back over the wire to Kali. And so you kind of think of Netcat as setting up a pipe or a tunnel between those 2 points. So if we send the ls command over this tunnel to Ubuntu, Ubuntu bin bash program processes the command and puts its output on standard out, which Netcat sends over the network. And our Netcat on our side, our client program, gets that data and it displays it to standard out on our computer. So you see the contents here. And you can issue any arbitrary command, but remember they're running over on the Ubuntu box. So we've seen how to use Netcat to send simple arbitrary data back and forth, to send files back and forth, and to serve a shell over 2 points. Now you can also do these in reverse. So for example, if you needed to send a shell over to Kali Linux, who was listening, we would set up to listen on our side. So let's see what our IP address is, and it's 138. So we're going to listen for a connection coming from Ubuntu, and we'll choose port 99 again. And now we're going to connect from Ubuntu over to Kali Linux. And we're going to push over there a shell from this Ubuntu server. So let's go back over to Kali and we'll type in ls and hostname just to be sure which machine the command is running on. And as you can see, it's running on Ubuntu. You may wonder what difference does it make about the direction, but depending on how firewall rules are set up or your position on the network, you may not be able to have an unsolicited connection from point A to point B, but perhaps you can have a connection from point B to point A. So being able to push files or shells back and forth in either direction is a very handy skill. We're going to be looking at finding out what the HTTP methods supported by a web server are using Matilde as an example web application. So Matilde is a free web application that contains vulnerabilities on purpose to allow pen testers to practice, also to be used in training environments to help web developers learn better coding techniques. It's available on irongeek.com, and there's installation instructions on IronGeek's site. Our lab is going to be a VirtualBox network with Windows XP acting as our web server. Matilde is installed and Backtrack 5 running as well. We're going to switch over to the Backtrack 5 machine, and first thing we need to do is figure out where the Matilde machine is on the network. We're going to use nmap to figure that out, and we know it's going to be one of the first couple of machines because the way that the VirtualBox network sets up on the host only setting is starts out with 192.168.56, and then it's going to be /24 network. The DHCP starts from 100, so we're going to start looking from 100 and go through 102. It should be either 101 or 102 since we only have 2 machines running on the VirtualBox network. And it just depends on which one of the machines started first as to which one it should be. So we'll let nmap run. Looks like it's about 70% completed at this point. And and looks like the results are coming back now. So I found the Linux box on 101. It looks like the utility is going to be 192.168.56.102. And there the results are. It's running an Apache server on port 80. So to find the HTTP methods, the easiest way is to use the options. We're going to use Netcat to send the options header across the wire, and if the web server has options enabled, it'll come back with all the HTTP methods supported. So Netcat, then we need to put in the server's IP address or host name and the port. Then we're going to send options. Syntax is the word options, then the site, and we're going to be using HTTP 1.1 protocol. We're going to send the host HTTP header field. It's a little bit redundant, but HTTP 101 demands the host header. And 2 carriage return line feeds. And the server responds with a list of allowed options: get, head, post, options, and trace. Another way to do this would have been to use W3AF. A little bit easier because it doesn't require the knowledge of how the options header works. So in W3AF, you put the target URL here. Then under Discovery, choose the allowed methods. And for output, choose your output. We're just going to use console. We're going to hit run. Wait for a second. We're going to go to results. Click on allow methods and methods. And you'll see that it simply ran the options itself the same way we did, and then comes back with the same information: get, head, post, options, and trace. SickOS version 1 is a nice virtual machine put out on VulnHub to allow people to practice in a safe environment. So we have SickOS running in VMware, and one of the things we're taking note of is that it's connected to the host-only network. That way we know which network range it'll be inside of. Also have Kali Linux running, and it is connected to the host-only network as well. And Kali is actually connected to the internet through NAT, but the second connection is on the host-only network. So if we look at our Kali Linux box, we can see that this connection is over 172.16.0.134. This means that the SickOS will be somewhere in this range. So the first thing we can do is we can try to figure out what the IP address is, and we'll just try a ping scan. So before we get started too much, I do want to emphasize that there's no right or wrong answer other than finding root access and getting the flag, which is the flag available in this particular exercise. And also, there's really no implicit order. It seems like some things would have to come before others, like discovering the IP address of the host, for example, would come before getting root access. But the idea is that this is just one particular way to solve this challenge, and there's probably dozens of other ways that are just as good or better. So to start with, we're going to do this ping scan on the range 172.16.0, and we'll just search the whole range. Shouldn't take too long. One of the nice things to do in a ping scan is only show the open host, or the hosts that are responded to the ping, in other words. Otherwise, you can get back a lot of results that are not what you're looking for. And reason will tell you why the machine seems to be up. So reasons can be that an ARP reply was received, or an ICMP echo response was received, or something like that. So we have a few different hosts up. We have 131 and 254 and 134. Now 134 was us. Go back and look again. See, here's 134. So we'll assume that SICK-OS is the 131. All right, so now that we have that, change this to 131. And then we'll go ahead and do a ping scan. We'll just assume that the host is online. And we want to do a port scan. Why don't we just go ahead and do the top 1,000 ports, and we'll see what comes back. Now, if you think that there's more ports running than the most popular ports, you could do more than 1,000 ports, but chances are that we're not going to have a whole lot of ports beyond the top 1,000, because statistically speaking, it becomes unusual or unlikely that systems are going to have those ports open. But if you have time and the bandwidth, it doesn't hurt to try. So we found 2 ports here. We've got 22 and 3128. And by default, Nmap tells us that SSH and Squid proxy are running on those ports. That may very well be true, but just know that the reason that Nmap is saying that is because typically that's what runs on those ports by default. And so Nmap is just making a good guess. And to verify if it's actually correct, we'll go ahead and do a version scan on those ports. So we have 22, and we'll put a comma, then 3128. We're going to go ahead and check the version of the service that's running on that port. And while we're at it, we'll run the default set of scripts appropriate for whatever version of that service is running, and check those out. Go ahead and let that start scanning. Now, technically, you could do all of this in one combined step if you wanted to, and that's okay. Nmap's smart enough to go ahead and do the port scan and find the open ports, and then only run the version scan on the ports it finds. So when the results of the version scan come back, you'll see that the NSC scripts from the -sc, they'll start running. And basically what they're going to do is they're going to interact with the services on that port and gather a bit more information than you can normally get by just doing a simple port scan or even a simple version match. So we see this information's come back, and we have port 22 open and 3128, and we have confirmation that it's Squid proxy. In fact, we even get the version 3119. So a good step to go from here would be to go out to ExploitDB or other sources and look up any issues that are known to be on this version of Squid proxy, and then we would do the same for OpenSSH 5.9. So in our case, we're going to go ahead and push forward on 3128 and see what websites we can access via that port. Alright, so to make this a little bit easier, we're going to use Burp Suite. It knows how to connect to a proxy really easily. We'll just take advantage of that. So we'll start Burp Suite Free Edition with the defaults. And one of the things we can do is we can set an upstream proxy. So if we go to the user options and go to the upstream proxy server, we can add one in here. And we said that we wanted to see if we could get to any websites on this host. So in this case, we're going to put the same IP address in the destination host, the target, as we are in the proxy host. And the proxy was running on 3128. And there wasn't, I'm not going to set any authentication. And we're basically going to hope it's not authenticated. So we don't have any credentials. All right, so now we got the upstream proxy. So just to kind of walk through what's going to happen here, we got Firefox, and Firefox wants to normally just go directly to a website. So what we're going to do is we're going to say, hey Firefox, go over here to Burp Suite. So we're going to set up a proxy, and we'll use this profile here, which is localhost, because that's our Burp Suite's running on our localhost, and on port 8080. Now, how do we know that for sure? Well, if we go over here and look at the defaults in Burp Suite, under proxy options, we'll see that by default, Burp Suite runs on localhost 8080. And we've just matched that exact same profile over here. This little tool here is Proxy Switcher, and it's an add-on available for Firefox. So if you don't have it, you can go to Mozilla add-ons and add Proxy Switcher. You can also manually set your proxy the old-fashioned way. Just go to Preferences and then the Network tab, or Advanced tab, Network tab, Connection, Settings, and you can set it all up in here. But you can see Proxy Switcher did a nice job of doing all that for us, and all we had to do was select our profile. Alright, so now that all that's set up, let's make sure that this chain's working. So we got proxy, intercept, turn the intercept on, come back over here. And we want to go to 172.16.0.131 and see if there's anything running on port 80, for example. It might also try 443, another common port. Okay, so let's go back over here to Burp Suite. And in Burp, sure enough, there's a GET request going out. Now remember that Burp is going to forward this on to Squid Proxy on 3128. So I'll go ahead and let that forward. In fact, we can just turn the intercept off. And sure enough, there is a website running on SICK-OS on port 80. You can try 443 as well, or you could really try any port you wanted. But obviously 80 and 443 are the two most common. Wasn't anything found on 443. Alright, so we have this website. You may want to just look around, do a view source and all those kinds of things. Do your normal stuff like robots.txt and see if you can find anything in there. And it turns out there actually is something there, so disallow on Wolf CMS. So that's very interesting. We'll have to check that out later. And while we check that out, why don't we go ahead and get Nicto running. So we'll do a Nict2, and we're going to run, in fact, I've already got this written down on how to do this so that we don't have to type it all out. Okay, so we'll walk through this. Back this up, paste. By the way, paste in Linux is Shift-Control-V. Copy is Shift-Control-C. It's kind of like Windows, except for you have to add that shift in there. So we have Nict2, and we're going to use proxy because we want to use an upstream proxy, just like we did with Burp. And the upstream proxy is located, again, at 131, port 3128, what we've been doing for the last few minutes. And then we're going to set the host to 131 as well. Now, of course, that would be on port 80. You could actually specify port 80 if you wanted to, but Nict2 is going to run by default on port 80. And if you're not sure about the options in Nict2, you can do the -H, and it'll tell you things like how to set the port and how to set the host. Now, one of the interesting things is it doesn't actually tell you about the use proxy, but the Nict2 manual online is really well laid out, and it'll show you how to do that if you need an example. So we'll go ahead and get Nict2 running, and while that's cranking away, we can also go over here to Firefox and look at that Wolf CMS. Of course, if you have the paid version of Burp Suite, it would do all this for you with its scanning features. So sure enough, there's a Wolf CMS, and there's probably some different articles. May even be a search feature we could use to try to get some more information. Some archives, articles, look around in there and see what you can find. There's a spider feature in Burp Suite that's pretty nice because it can do that spidering for you. So let's go ahead and right click and say add to scope on that 131 address, and what that would let us do is show in scope items only. To open up that little bar there, just click on this gray area up here, the menu bar there. Kind of doesn't look like much, but it actually is a button. And then if you wanted to, you could use the spider to go through that Wolf CMS for us by saying spider this host. It's pretty cool that that feature comes with the free version. And you can see it'll start the spider here in the middle and pull down some different pages. Okay, so while that's going, let's go back over to Nict2 and see if there's anything fun over here. So we got Alright, so no cross-site scripting protection header in there, and content type options, and no cache control, and no clickjacking protection. So a few minor vulnerabilities, medium level vulnerabilities. But this one here is pretty interesting. So the site appears to be vulnerable to shell shock on this particular page here. So the status page is something you'll find on websites occasionally, especially Java websites, Apache-powered websites. You'll see a status page that just tells the administrator how the site's doing, the uptime, and things like that. And it happens to be that this particular one is vulnerable to shell shock. Now this is running at least a PHP site in our case, because there's these PHP Easter egg files there as well. So let's go ahead and take advantage of the shell shock. And certainly Burp Suite is a nice way to do that. So let's see if it found the little bin. It didn't. Looks like it didn't find the CGI bin. So we'll just manually browse to it, and it'll add it automatically to the tree. All right, CGI bin, and it was status, and there it is. Right, so now the page has been added. Should see it appear over here. Status, right click. So we're going to right click on that. We're going to send that over to the repeater, and we'll just replay it, make sure it still works. Great. So we repeated the request from prior, and we got the same response that we got prior. All right, so for the shell shock, again, let's go out to the cheat sheet, but just know you can find any of this information by Googling, or you can just copy it from this video. So to start with, let's do something easy. And we'll just do an ls to confirm that this is working. So we're going to take advantage of the user agent field. Certainly one of the more popular fields when it came to shell shock. So what we have is this part right here just sets up this prefix. It's basically setting up the injection. What it's doing is it's getting the syntax just right to take advantage of the vulnerability to switch context, as you might see sometimes online. And then the actual payload starts. And what the payload does is it takes advantage of the fact that the exploit has gotten bash into such a state that it's willing to accept our commands. And so one of the things we need to do is when we're dealing with web content and shell shock is you want to set up the content type so that over here when you get the response back, that the web server will be willing to print out whatever the response is from bash. So if you say echo user bin who am I, that'll come back from bash as text that would normally go to standard out. And this content type header that you incorporate into the response will let the web server include that content as just text, plain text, into the response. So let's give this a try and see if we can get it to work. And it looks like it's working. So notice one of the keys is that the this is an injection, so there's not really going to be an environment per se set up. So what you want to do is make sure that you give the full path to whatever program it is you're trying to run. So like say you wanted to run ls to list contents of a directory. All right. So over here on our Kali box, the one we control, we'll do which ls, and it tells us that ls is in the bin directory. All right. So we go back over here and we can change this to the bin directory easily enough, and then change this to ls. And so we can do ls la root, for example, and go ahead and send this off. So there we go. So now we have the general idea of how to get the shell shock working, and now we can pretty much run some commands and start trying to figure out what's going on with this sick OS. So we want to start off with listing etc password. It's not a bad place to start, and that'll give us, sure enough, there's a file etc password and it's readable by everybody. All right, so now let's print it out. So we're going to change the ls-la to cat. Bin cat, again, if you weren't sure where cat was, you do which cat. It's in bin cat on our Kali Linux box anyway, so we'll just assume it's in the same place on SICK-OS. And there you go. It's printed out. So this is a really good thing to have because now we have a list of accounts. Now the ones that have an actual legitimate shell after them, like root or this statement here or whatever, are more interesting than the ones that are deliberately disabled. Like you see here, message bus has a default shell of bin false. MySQL has a default shell of bin false. No login on the SSHD. So those aren't as interesting because you can't really log in remotely with those accounts. But accounts like SICK-OS, for example, has bin bash. So now that we have this list of accounts, we want to write that down. And a keep note is a good place to kind of keep some of these notes. And so here we have the accounts, and we've also just filtered out the ones that don't have a legitimate shell behind them. And so the one that's not like the others here is SICK-OS. So if you look at the other accounts, they're basically default accounts or accounts that are associated with programs. Not that there's anything wrong with accounts associated with programs or service accounts, but a lot of times they have restricted privileges or they can't log in or there's other controls on them. These accounts that belong to users are the most interesting of all, and obviously the root account itself. So let's just remember about SICK-OS being there. All right, other parts of the file system we want to check out would be the web directory itself. So if we go back over, if we look at the root again, we see there's var. Typically the web is going to be in var www in a lot of situations. So let's print out var. We'll hit go. And we have some interesting directories. We have www. We also have backups. Backups is really interesting. If we look inside of there, we see that there's actually backups of the shadow file. That would be great if we could get that. Notice it's owned by root, so having access to that file is basically equivalent to having root access itself. Not to say it's not worth trying to get it, but it would be easiest if we were already root. So it's sort of circular reasoning there. Now we go inside the www directory and we get some other files that are interesting. This bash history would be interesting. It's owned by the www.data account, and we actually are running as that. If you recall back when we did the who am I, we were running as www.data. So even though it is read and writable only by the owner, as it turns out, that's the account we're running as. So let's go ahead and give it a try. So we do bash underscore history, and we'll have to change the ls-la again to cat. So we're going to do that. All right. So we see that down in here that SICK-OS has been doing some sudo su and some other stuff, which is very interesting. We don't see a sudo-l in here, which would actually tell us what privileges SICK-OS account has. But the fact that we see these commands down in here indicates, oh, there is actually a sudo-l. So these indicate that this account is actually able to go into root. So, all right, so we'll go ahead and back this one on up. There's the Wolf CMS. So let's get down into that a little bit more. That program is a CMS, and it typically has a database on the back end. There's an HT access. If you see an HT password file, those are always interesting. All right, we have a config.php. Definitely want to check that out. So that file is, it's owned by root, but it's readable by everybody. So let's go ahead and dump it out. So even though it's owned by root, don't give up. Let's look at the permissions, and if you can, dump it out. And there's the database settings. So that's really interesting. So we have a root account, that's database root. And we have password is John@123. and that's going to connect to localhost port 3306. And we can't actually connect to the MySQL account very easily from our current position. Reason being is that it only runs on localhost. Okay, so we got some good information there. So we know SICOS is an interesting account name, and we know John at 123 is an interesting password. Maybe we get lucky. Maybe the person reused their password. Let's give it a try. So we'll just open a new window, and we'll do SSH, and we said the account was SICOS. It was, in our case, at 172.16.0.131. And then we'll have to give a password once this connects up. And let's try John at 123. We also perhaps use Hydra. We're going to paste that password in there so I don't mistype it. And we get logged in. Great. So we're the SICOS account. Now that we got logged in as this account, we have a direct access to the system. So one of the things we could go ahead and try to do would be to just look around some more, see if we can find any privilege escalation. But let's do that sudo-l, and we'll have to put in our password again. So that was John at 123. And this is great news. So now we actually have the ability to run pretty much anything we want on this host. So if we did a sudo su, then now we become the root user. So now this is going to get a lot easier. All right, so let's go into the root directory, do an ls, and there's the flag. And then we'll print out the flag. So that's one possible way to solve this challenge. There's a lot of other things we could have done. Let me give you some other things to try. The CMS would have been a good thing to look at a little bit more. We didn't spend much time with that. Also, on the shell shock, we could have gotten a shell, not a terminal. The SSH terminal is really nice. That was great. But we also could have got a terminal using this command here with the shell shock. Now, in order to do that, you would need to set up a Netcat before you run this command. So let's just walk through that real quick. So see how that is going to go to us. Remember, we were at 134, and then we're saying port 443. That's somewhat arbitrary. As long as the firewall is going to let the connection out, then you can pick whatever port you wanted to. And so if you wanted to set up that connection, what you would need to do is do something along the lines of a netcat-listen, and in this case we picked port 443, and so you would set up that listener there, and then you could use this bash over in your burp suite to try to set up that connection. So and that gives us a reverse shell. Again, shell, not terminal, so it's not quite as awesome as the terminal is, but you can still run commands in it, and a lot of different commands. There are some commands that won't work, like the switch user won't work in a shell. You have to have a terminal, so you need to escalate using one of the other tricks that we did. So hopefully you enjoyed this video, and again, I want to emphasize this is one possible way to solve this. There's lots of different ways. Definitely encourage you to try some different things. One thing you could do is even use this way to get some root access and then wander around the system a bit more and see if you can figure out some other ways to solve this challenge. So to start with, I've got 3 virtual machines running. The first one is Kali Linux here, and then I have Ubuntu and Windows. This happens to be Windows 10. But it doesn't really make that much difference. So Netcat is already installed on Kali. If you type nc or Netcat, which you can do nc-h or Netcat, both work either way. And this is going to be what they call the Netcat traditional version. On Ubuntu, Netcat is installed by default, but it's going to probably be the Netcat BSD version, which doesn't have one of the options that the traditional does for safety reasons. So if you type, I believe it's Netcat V, let's see, Netcat, let's try H. It might tell you the version. I forget the command to do the version. Sorry about that. Oh, there it is. Yeah, 1040, whatever. So this is Netcat traditional. So what I did in Ubuntu is I uninstalled the default version, if you will, and then just installed the regular Netcat. Now to do that is really simple. You just do the apt-get and remove, and then type in Netcat, and then you turn right around after that and do Netcat install. I'm sorry, apt-get install Netcat traditional. So it'd be like Netcat or install Netcat, and then it's going to be traditional after that. And if you use the tab completion, it'll help you. You know, like if you try to tab complete it, it'll give you hints and stuff on how to spell that. So hopefully that makes sense that on Ubuntu, if you want to do everything that we look at today, you'll have to have the traditional version. All right, and on Windows, it's a precompiled binary that you can download from the Netcat website, and it comes as a executable. Now on Windows, I'll warn you that some antivirus programs see Netcat as a threat. So if you want to install it on Windows, you need to make an exception for the folder that you put the Netcat into if you have one of those antivirus. If you paste Netcat into the folder and it just vanishes on you, 99% chance the reason is that the virus scanner ate it. So, all right, is there any questions on kind of how to get the environment set up so that you're able to do some of this? Okay, so we'll go into, start out with what Netcat is. Well, it's a program, and it talks over TCP or UDP connections, and it can send arbitrary data over those connections. So part of it is that it's a client, which means it can send data to places and receive data from places. So for example, I've got a website running on this Ubuntu here. Let's see what the IP address of Ubuntu is. So it's 129. Okay. And we can double check that the website's actually running. It'll be localhost from this point of view. Okay, great. So everything seems to be working fine. So if I netcat over to that IP address, we can see what happens when we send this packet. All right, we'll just make up some stuff to send to the web server. And of course the web server is not too happy with this, seeing as we sent garbage over there. But as you can see, some traffic went from our machine over TCP, ended up at the web server, and the web server responded. Now to kind of take a look at that, what we can do is we can record these packets and then look at them in Wireshark. So you could use TCP dump, for example, to record the packets, or you can just fire up Wireshark if you want and just capture the packets right away. So either way works. And of course, looking at the packets in Wireshark is not mandatory, but I think it kind of helps get an idea of what's going on to be able to sort of see the interaction at the packet level. All right, so we can do capture and let's see, refresh interfaces. Okay, I'm going to pick this ETH1 because I'm not sure if you can see that address, but see how it's on the 172.16 network? That's the same network that the Ubuntu was on. All right, so we'll replay that same connection from earlier. Okay, there we go. So if we go back over to Wireshark, you can see that to start out with, Netcat sent a send packet,
and the Ubuntu server responded with a send ACK, so we have, and then there's an ACK. So we have the three-way handshake. There was a TCP connection established. And then after that, the data started flowing. You can see the word hello that I had typed, plus the line feed there at the end. The 0A is a line feed. And then the server eventually will respond back to us. And somewhere in here will be that blank stare that it gave us about, that's not supported, and I don't know what you're talking about, et cetera, et cetera. If you're in Wireshark and you want to be able to actually see the conversation, if you right-click on one of the packets that's in that flow, and you can do follow TCP stream, and that'll give you just the data that went back and forth without all the TCP stuff underneath of it. So you can just kind of see the interaction between those two. And also, if you go under, I think it's statistics, or let's see here, conversations, then we only had one conversation going, but you can kind of see if you have like a bunch of TCP conversations going back and forth, you can come over here and figure out which conversation you were in. Or you can kind of go the other direction and use the packets to figure it out. So over here, if you look at the TCP packet, open that up, see how there's a stream index? That's a number that Wireshark adds to the conversations to keep track of them. So when I right-clicked and I said follow the TCP stream, how Wireshark knew all those packets belonged to that same conversation is it was keeping track of the conversation as it flowed in, and then it was adding this stream index. So if you have 3 conversations, the first one's going to be 0, second one, third one 2, and it just kind of keeps keeps track of them that way. And that'll allow you to go up here and just type in like TCP stream or UDP stream equals 0 or 1 or whatever, and you can follow those conversations. So there's a few different ways to kind of keep track of these packets. All right, and the other part of Netcat is that it has a listener, so it can also be a server. In other words, a Netcat can talk to a Netcat. So over here on our server, we could say Netcat and then have it listen, which is -L on a port that we name with the -P option. So why don't we use just 9999 for no particular reason. And over here on the client side, we're going to change our port to 9999 to match the server. Over here you'll see that the word hello showed up. And we can type back and it shows up over here. So it's kind of acting as a very simple chat program at this point. But it's not a chat program. It's just doing what it does, which is if you send data over this connection, it'll make sure that the data gets over to the other side for you. It's kind of simple in that way, at least conceptually. It's kind of simple in what it's doing. I'm sorry? Yes. Yes. Now that they're not talking over commands right now, so what they're doing right now is they're just chatting back and forth. So good question. Let's get a visual on that. So if I go ahead and start up a TCP dump, so we don't have to have Wireshark kind of graphically showing all the time, we'll do that, and then we'll capture that traffic and look at it and be able to see it better. Let's see, new terminal. So TCP dump can write down the packets as they go back and forth, and then later we can view those in Wireshark without actually having to have Wireshark kind of running all the time. So the -W is write the packets to a file called packets.pcap in this case, X will show us more information on the command line. V is for more verbosity, and -NN keeps it from trying to go out to the DNS servers and resolve these IPs. We can also do filters, kind of like we can in Wireshark. So again, the IP over here, remember, was 129. So we can just say, I only want to see traffic or capture traffic from 129. That'll keep the packet capture a little bit cleaner, because there's probably going to be some broadcast packets flying around the network as well. All right, so notice over here that the server program, when we terminated on the client side, the server program terminated over here as well. And we have to restart it. Okay, so now if we, let's see if we're capturing here. Okay, let me check out TCP dump, because I don't think we got any packets. All right, nice. Demo is going exactly as planned. First mistake needed to occur at exactly 25 after for this to work. Okay. All right, see if we can figure out why it's not capturing. Let's try specifying ETH1 to see if that helps, and verify that we're on ETH1 over here. The interface, in other words. So our interface that we're using is 134, and its name is ETH1 or ETH1. Okay, restart the server, start the client. Okay, and now you see how the verbose, when you have it in verbose mode, see how it keeps track of the packets it has captured. So it says 7 so far, which is a good sign. All right, let's have one more back. All right, and we'll kill the server side. Client side's dead. Stop the packet capture and open up Wireshark again. Okay, so here is our send packet again, send ACK and ACK, the three-way handshake. All that makes sense. And then when you see the push ACK, that should be the data starting to come from the client. Down here you can see it says hello again, and then the line feed. And the server responded back with an acknowledgement. Then there was a couple of chatty boxes. And then we have a push ACK again, so more data is flying across the wire, but this time it's going from port 9999 to our client side, from the server at 129 back to the client at 134. And you can see that it said I saw that mistake, and then the client side acknowledges. So hopefully that kind of helps understand how the program's working and what it's doing. It's just sending arbitrary random data over a socket. It's not really random in the sense it's made up, but it's random in that we just chose it, and Netcat, obviously is just sending whatever we pick to go back and forth. And if you want to see it again, you can right-click and say follow the stream. And of course, there wasn't much data in that conversation. All right, so let's go again, but this time, instead of sending arbitrary data, we can go ahead and do some data transfer. So I'm going to start up the server again, but this time, instead of just having this kind of chat feature working, I'm going to redirect the input. Now, if you're not familiar with redirection, normally what happens is with most programs that run in Bash, most programs that run in Windows command.exe for that matter, they're going to automatically take their input from what they call the standard input, which is usually the keyboard in most cases. Okay, so for example, and the operating system keeps track of that through file handles. It automatically, auto-magically, if you will, it opens up these files in the background that are just kind of, think of them as kind of like global file handles that are just sort of automatically there. Linux and Windows, they do that for you. You don't really have to set that up. Now, if you're a programmer, of course, you know, if you want to open a file arbitrarily in your program, you have to give it you have to ask the operating system for a file handle, and it'll give you back a number higher than 2, and you can interact that way. But these automatic files are standard in, which is 0, file handle 0, standard output 1, and standard error 2. So Netcat, it listens from the network, it listens on standard out, and it sends its own output to standard error, which sounds weird because it's sending its normal everyday output to the error. The reason it's doing that is it does not want to pollute the network traffic with its own output that it's saying. So if Netcat says, I just made this connection, it won't send that over the network so that the other side receives Netcat saying, I just made a connection. It'll send that to standard error. So to kind of demonstrate that a little bit, if we said hello, that's just going to go to standard output, which in our case is the monitor, it's the screen. Okay, and we can redirect that. So if we said, I'm going to send that to file handle number 2, which is standard error. Well, it's still going to come to the screen because it doesn't matter if you're sending it to standard out or standard error. It's going to show up on our screen. So to kind of tell the difference, you could do something like this. Sed is kind of like one of its features is it can do this replace with regular expressions. Okay. So if I send this to regular old everyday standard output, oops, I forgot a little slash there, I think. Ah, very good. Okay. So let me do that again from the top. This says replace instances of hello with goodbye, right? So hello was sent through the pipe operator to the sed program, and it faithfully did the replacement, and so goodbye was sent to the output. But the pipe, see, the pipe takes input in from standard out of the previous program. So if the echo program sends things to standard output file, then this pipe symbol is going to pick that up and pipe it over to the standard input of the sed file. That's what pipe does. So if we redirect this input to standard error, then we would expect that sed won't know that that happened because the pipe doesn't take input from standard error, it takes it from standard out. So see how in the first case the hello got replaced with the goodbye because the sed program got involved. But in the second case, notice how the word hello didn't get changed because we sent the output to standard error and the pipe symbol never saw it. And so it never had a chance to send it over to the sed program, so the sed program never got anything to do any work on. So I know that tends to be a little bit confusing, but hopefully that kind of helps demonstrate that there's a couple of different output options that Netcat is using. And anything it sends out to standard out is going to go over the network. Anything it sends to standard error is just going to show on your screen, but the other side's not going to see it. All right. So all that to say, now we can do redirection. So instead of having Netcat just take data from standard input, in other words, whatever we type on the keyboard, we can have it take in from a file, a different file. For example, if you wanted to get Etsy password across the wire, this might be a way to do it. So we start the program running, and it's just sitting there. It's listening on port 9999 for a connection to come in. And when the connection actually shows up, then it'll send input over the network to the other side. And in this case, the input's going to be redirected from this Etsy password file. All right, and so as soon as we make the connection, really you can't even hardly see it, it just happens so fast, but as soon as we make the connection, immediately Netcat listener, Netcat server on the Ubuntu sent the file over the wire back to the Netcat client. And they're still sitting there connected. They haven't actually hung up yet. So you can see the server is actually still running. But the redirection's already occurred, and that's pretty much going to be the end of the conversation. So at that point, you can go ahead and terminate your client or your server, whichever one. If anybody has any questions at all, just slow me down or say something.
What is 42?
Answered all things.
That's right. She wins a cookie, by the way. Okay, so 14 packets were captured in that whole long-winded exchange that took me 72 minutes to explain. All right. And over here in Wireshark, again, familiar, send, SYN-ACK, ACK, connection was made. Here's the push ACK. So data is going from, remember the server initiated the push, right? In this case. So what we should see here is we should see that file getting transferred, and sure enough, there it is. So the push occurred, and then the client acknowledged, and that was the end of it, right? And then you see the FINAX, which is the here the client running on that high port told the server, "I'm done," and the server said, "I agree," and they hung up on one another with the FINAX, and that was the end of that. Well, I guess the client did acknowledge the hang up, so it's being polite. All right, so hopefully that makes sense so far. Pretty straightforward, but there's a lot of stuff going on under the hood of both of that program, as you can tell. It's pretty neat program. All right, so we've been able to push arbitrary just text back and forth, files back and forth. By the way, we can move those files in both directions. So if you wanted to get a file over to the server side, you could set up that same listener. Okay, and then you could redirect it. So you can redirect the standard in that comes into Netcat, and you could, instead of letting it just print to the screen like we did on our client side, you can redirect that to a file. And it'll just sit here and wait for somebody to send a file over. Now in this case though, the server side is not going to know when you're done sending the file, so you'll have to kill the connection on the client side in order to kind of terminate this file, if you will. All right, so over here on the client side, we can send a file in. So we can send in the etc password of this computer. All right, I guess I went over there pretty quickly, because last time it took just a blink of an eye, right? So I'm just going to terminate the connection. Okay, and there's the data from the file. Notice how they neither one of them knew, oddly enough, that they had reached the end of the file, so they just kind of hung there, right? When you actually hit Control-C, that's when they'll send that FINAC to each other and terminate the connection. The file handle will close, and then the file will be completed, if you will. The file will be closed, and you can cat the file. So you can see the file here, and you can cat the file and do everything with the file. So that's a nice way to move data back and forth between the two computers. And it works the same exact way with Windows. All right, and since it does, I'm just going to switch to using Windows a little bit. It doesn't work any differently, just to kind of demonstrate that it works the same way. So I have netcat.exe in here. And this time, instead of sending a file back and forth, one of the neat things is we can send the output of programs back and forth, which is really cool. It doesn't just have to be a file. Now that has to be with the -E option. So we can listen on a port, and I'll stick with the 9999 this time. Oh, excuse me, let me go ahead and get the IP of Windows since we are switching computers. Okay, see, Windows is 137. All right. To send a program, to say redirect a program's input and output via Netcat, use the -E option. Let's go back over here to Kali. We have to change our TCP dump listener to 137 since that's Windows. Otherwise, we wouldn't get any packets. Okay, so when we connect this time to Windows, notice that what comes back is the output of the command.exe program, because that was the program over here that we said instead of having its normal output go here to the terminal, redirect it to this other program over here, Netcat, via this -E option. And then Netcat just does what it does, which is if you send input into it on then on standard in, then what it's going to do is it's going to pipe it over the network, right? And over here on Kali, the Netcat client is just doing what it does, which is if it receives that data, it's just going to output it to the screen on standard out. So now if we did like a dir, basically we're interacting with that command.exe program over on Windows, but we're just doing it via this Netcat pipe. So we can do whatever we would normally do right there from the computer. So you can change directories and list contents and all the normal stuff, run programs, execute it. If you do this with Netcat on Windows, the virus scanner might get really mad at you. So even if you've said that the file is okay, if you've marked it as the file is non-delete, this behavior might set off some alarms. There are some antiviruses that you can sort of kind of like whitelist a folder, but it still gets mad at you if the programs in the folder do something bad. So like I want to say Semantic Endpoint Protection Enterprise has that kind of behavior where you can't really like tell it not to worry about stuff very easily. Whereas if, for example, Microsoft Defender, if you tell it like everything in this folder is fine, it'll just let it do whatever. Like it just completely ignores it. So your results may vary, I guess is my point on the antivirus. All right, well, shoveling a shell back and forth obviously is a really fun exercise. And it's a shell, it's not a terminal. So move this up so you can kind of see it. I issued the CLS, the clear screen command, and it ran fine. I mean, but you'll notice that it didn't actually clear the screen. That's because you're talking to a program over the network. You're not in an actual terminal program talking to command.exe. You're in Netcat talking to command.exe. So just kind of keep that in mind. If you're doing something that only a terminal can do and you're just not sure why something's not working, it's not a terminal. So if you do something only a terminal can do, then it's not going to work over a Netcat connection. All right, I'm going to kill that connection and go back over to the Wireshark. We got all kinds of packets that time. Okay, well, I think this is the beginning of the conversation here because there's a SYN-ACK, and ACK from the two sides. The client port's a little bit different this time. And we have the first push here, and that was where it was starting to tell us that the command shell had opened up. And I'm definitely going to follow this one on the stream because it's a lot of input. But you can see, like, we would type in dir, and then that would go over the wire and come back. The output would come back, and it would be the directory listing. You can see the different commands that were run, et cetera, et cetera. So, all right, any questions on file transfer, hooking up programs to the actual pipe? Anything up to this point? Okay, cool. All right, so another thing it can do is port scanning. Basically, Netcat can send arbitrary TCP UDP, right? So if you tell it to send TCP packets with the wait option, meaning only wait like say a second for the packet to come back, and then use this zero input option, which is kind of like more or less the scanning option, then you can have it basically set up as a scanner. So if we say 172.16.0 and 129, that was Ubuntu, right? And we said scan ports 78 through 84. Let's see. It says 80 is open, which is kind of hard to see, but it's right there. So basically, that means that that web server we already knew was running is running. So when Netcat scans, though, and actually this is probably good to see kind of in, I guess, in action. So let me start up the listener. Run that again. Oh, we have to listen on 129 because I switched up the computer again. All right. Kill that. All right. The reds are those resets, reset acts. All right, so there's a send packet going out, and basically what we're getting is a reset act. So because see how that one went to port 84 and that one went to port 83? Well, on that Ubuntu, those ports are not open. So whenever Netcat sent the send packet, the operating system, Ubuntu, it responded with the reset act. But look what happened when we got down to 80. So when we got down to 80, we actually got a send act back from Ubuntu. And then our side did an acknowledgement and exchanged a little bit of data. And then finally we had a hang up, a FINAC, and then an acknowledgement on the hang up. Okay, so what's interesting about that is a few things. First of all, it scanned in reverse order, but it was sequential. So that's going to get picked up right away, right? If anybody at all is paying any kind of attention at all, a sequential scan is going to get picked up immediately. Also, another thing that was interesting is this was a full connection. So when the port actually was opened, a connection was established between the two sides. That actually can be a little bit stealthy in a way. Most of the network tools are kind of sensitive when they see send packets that are unsolicited that result in a reset act, because that's a common pattern for a scanner. But you can kind of hide in plain sight a little bit more if you're doing full connect scans to some extent. Now, depending on the resource you're reading, you may see someone contradict that, because a full connect scan causes the other side that accepted the connection to actually log that. So it depends on your perspective. Are you watching the traffic flow, or are you watching the connections on the actual host? A send scan doesn't result in as many logs on the host side, but it's an obvious traffic flow. So, and then the other, the vice versa. All right, so a few tips on running this. And I guess this is more for if you're kind of doing this like as a pen tester type scenario, as opposed to if you're doing this just for fun or whatever. But when I picked the port, I kept picking the 9999 port. And there's nothing special about 9999. In fact, it may actually be kind of stick out like a sore thumb. But the point is this port number was higher than the 1023. So if you're a process and you're trying to open up a port on an operating system, and you want to open up that port in the low range or in the extremely high range, above like 49 something or another, then you have to be a root or administrator to do that. And so those ports that are under like 1024, those are suspicious from a connection point of view, because it basically means a service is started, and it was started by a process like a NIT that has root privileges. Those are going to be a little bit more obvious for folks that are watching the network than something that's like, 4762, just whatever, right? Just make up a number, because those are high ports, which means they're not privileged. They're not privileged ports. All right. And again, this is all highly context specific. So if at your work it's the opposite, that's fine. But I'm just talking about generalities here. Okay. And you kind of want to look at like what SimTools do and kind of what the rules look like to sort of figure these things out. So from a IDS point of view, Netcat is just going to blend in with TCP traffic, but notice that none of this was encrypted. So your traffic is going back and forth in clear text. Now a kind of an offshoot made by the Nmap people is NCAT, and it can do encrypted connections. So if you want to keep the traffic encrypted as going back and forth, that variant of Netcat actually has the encryption features built in. And so that might make a little bit more sense if you're worried about somebody seeing what you're doing. And again, that's kind of from a pen testing point of view as opposed to like a network administrator. If you're a network administrator, you definitely should be doing whatever you're doing over an encrypted tunnel or using, encrypted tools, because the bad guys are watching too, right? So they're watching to see if they can pick anything up on the network as well. So one trick you can kind of use if you're having trouble getting to a box over a network, or for some reason you can't connect directly to the box, or you don't want to connect directly to the box, you might set off some alarms, is you can set up a relay. This is going to kind of put together everything that we've looked at so far. So Windows was over here. And it was listening on 137. Just kind of have to keep that in mind. Ubuntu, 129. And Kali was, I believe, 134, but let's just double check it. Okay, so 134. All right. So let's say that we're trying to do that same trick with Windows. All right, so I'm going to start the listener on Windows, and it's on 9999. So we may have to adjust some things in the middle here. And I'm sitting over here on the Kali Linux box, and I want to talk to the Windows box, but I either have to or want to do it through the Ubuntu box. Well, because Netcat is just listening on these arbitrary TCP sockets or even UDP sockets, we can actually make a Netcat relay in the middle and pass all the traffic through this middle box, if you will. So it starts off with we need a pipe, because you remember we have the pipe symbol, the pipe program that works fine, that pipes data back and forth. But we're going to need a second pipe, and I'll show you why in a second. So we're just going to make a second pipe. We'll call it the back pipe. And I believe it was Ed Scotus that originally showed me this, but there was another SANS instructor that also has a great write-up on this on, if you just Google it, Netcat Relay. The other SANS instructor, whose name is escaping me at the moment, had a really nice web page that kind of walked through it. All right, so now we have our other pipe. And we're going to do Netcat listen on port. So we're going to use a different port here because the 9999 is taken up by the server side. So we're just going to use all 7s. Okay. And here's the part where it gets kind of weird. All right. So when this Netcat program here, move it up to the tops there. So when this Netcat program here starts up, it's going to be listening for input to come in via standard in. And whatever it gets, it's just going to send it over the network on port 7777. I'm sorry, it's going to listen for traffic to come in over 7777. This is the listener, -L. And so if it gets this traffic that comes into it from the network, normally it's just going to spam it out to the screen, right? But one of the things that we could do is, this is standard in. We can say, okay, if you see anything on this back pipe, send that to standard input instead. All right. Then we can use a regular pipe, and we'll connect it to another Netcat program, a separate process. All right. So Windows was at 172.16.0, and it was 137. And it's listening on port 9999. All right, and one was standard output. So what we can do is we can say anything on standard output, let's send that over to the back pipe as well. So this Netcat here on the left and this Netcat here on the right, they're now connected through this second pipe that we made. I mean, they're also connected through this first pipe we made as well. But remember, the first pipe is only works in one direction, right? It only works if this Netcat is trying to pass data to this Netcat. So if we get standard out on this program, it'll go through the pipe and into the standard in on this program. But we want that to work in the backwards direction too. That's why we have to make the back pipe. So now we have the standard out on this program going to the standard in on this program. In other words, it's going this way. The traffic's going to the left through the back pipe. So it goes to the right through here, and it goes to the left through here. And in other words, it's now basically working in both directions. It doesn't matter which direction the data is flowing. All right, so the program over here is still running, and it's listening on 9999. Nobody's connected yet. All right. And if we start these two programs running, now this one is connected on 9999 to Windows, but this program over here is listening on 7777, and nobody's connected to it yet. So back over here on Kali Linux, kind of get to the punchline. So we want to connect to Ubuntu, which was 129, and we have to be careful that we're going to do that on 7777 this time, since that was the port of the left side listener, if you will. Not that left and right really matters, but the client side listener. It's kind of oxymoronic. It's a listener, it's a server, but it's a client side listener. But anyway, you know what I'm saying.
Yeah.
So it's because we have so many. We got two listeners and two clients, right? So we have a server side listener and a client side listener. Okay, so now we can see that we've connected to Windows, but we actually did it through 129, which was Ubuntu, and it all works the same way. But in any kind of traffic flows or logs from Windows's point of view, this absolutely is all coming in from Ubuntu. From its point of view, that's the only connection it knows is through Ubuntu. Whoops, let's see here. Let's see if I can get the mouse to open up another prompt. Oh, looks like Netstat's taking its time. I was trying to see if there's any 9999s in there. Oh, sorry, did I pass it up?
There you go.
Cool, thanks. Oh, yeah, thank you for that. So you can see from Windows' point of view, it's connected to 9999 on itself. That's 137. In Ubuntu, it's the client port is this random 59475 chosen by Ubuntu, but the IP address is 129. And all the other stuff we talked about, it works the same way. So the file transfer, because all of that was just redirection, right? It didn't really matter what it was you were redirecting. Standard in, where we were typing files that we were redirecting with the less than, greater than operators, or programs using the -e option. In all cases, it was just, it's nothing but redirection, sending it over this network pipe. Right, so if we hit exit, that kills the shell program in Windows. And so the Netcat listener on the Windows side just kind of died. The Ubuntu one's still running. At least this half of it is. Although it wouldn't work very much anymore. So to kill that, you would just Control-C. And then over on the client side, when we hit Control-C in the middle, it killed the client side connection. All right. Now, one of the things you might have noticed is that this is not very persistent. And there's not really a very easy option on the Linux side to make it persistent. But in Windows, this is kind of a cool feature. So check this out. On the Windows version, I'm sorry, go ahead.
In Windows?
Oh, yeah, there you go. The Windows version, there's a capital L instead of a lowercase l. And it does the same thing that the lowercase l does, except for it's a persistent connection. Okay, so if I go back over here and just do the simple client, so change that to 37. Oh, I might change these to 9s as well, I believe. Make sure, yep, 9s. Okay. All right. Now, at this point, we can kind of like terminate our connection on the client side, and it stays running on the server side, and then you can reconnect. That's a really nice feature because it gives you persistence on the Windows side. Again, not saying that the antivirus or the network guardians aren't going to notice that persistent listener running, but obviously you could run that persistent listener and using any of the auto run tricks, the registry keys, there's about half a dozen of those things now that auto run, and then all the startup folder and all the old tricks that have always been around. On Ubuntu, you can, or Linux in general, you can kind of do the same thing. You do need a little bit of a script, and I wrote one here called 9 Lives, and it comes straight from that fellow's website that I was, unfortunately, whose name I can't remember right now, but basically I got the idea off of there. Also, Sans has published a cheat sheet, a Netcat cheat sheet, which is just full of all these different commands I've talked about today, and it includes this little shell script or some variant of it as well. So basically all it is it's a loop that runs forever until you kill it while true, and it says some words, and then it creates a listener, in this case on 7777, and this one happens to be a shell listener as well, kind of like the one on Windows. Okay, so you run that shell script in this loop, and then so we are on 7777. Oops, I'm still connected. I have to get out of this one. Let Windows be free. All right. Okay, so now we're connected over here to the Linux side. I'm going to kill the connection with a Control-C. And you can see that the loop circled back around. It reprinted the text, and then it ran that same exact command again. So it's not really truly persistent. It's just that the shell script just loops back around every single time the process dies, and it just fires it back up again. So it'd be a new process ID every time if you check the logs. All right, connect again. And there we are. Kill it again. And we still only used up 3 of the lives, so we're good. All right. Any questions on persistence? And again, you can chain all these tricks together so that you can chain the persistence with the tunneling and the relaying and all that stuff, the file direction, however those Lego blocks need to assemble to get your job done, you can just put those together. There aren't any of them that I'm aware of that exclude or preclude using the other Lego blocks. All right, and one other trick that's kind of neat, if we can get it to work. Let's see. I apologize for the ad chart there. Let me get a. Let me make sure that in Ubuntu that since we're using that as a server that I've got like SSH running. All right, that's never going to die. So you can do the old PS AUX, get the PID, kill it, blah blah blah. Or you can just do this. So. Okay. I don't know if I've got SSH running. That's what I'm checking. Yeah, I'll give it a go.
Just so you know, it is one spot, so you gotta go. That's cool. We'll just write your name down.
Oh, okay. I think it is running. So, all right. We'll try it here in a minute and see if it works. See if I can make this a little bit bigger. Bigger. Here we go. Awesome. So that is funny key plus symbol. All right. If you say so. On my laptop, it's funny key. for what I paid for it, I get to name it. So there we go. All right. All right. So
Sound you hear is Steve flipping over.
there you go. All right. So let's say, for example, that we wanted to connect to Ubuntu, but we wanted to start this connection out with a tunnel so that it would be hard to detect that. Let me see if I've got it. Let's see, service. Make sure everybody's got SSH running. Okay, so now I believe Kali's got SSH running as well. All right. So over here, this happens to be a Mac, but it doesn't really matter. It's just kind of a variant of Linux for purposes of this demo. So I've got a key already set up on my Mac to connect over to Kali so that I can remote in safely and all that kind of fun stuff. And one of the things we can do is we can use this -L option, which sets up, L is, I believe, for local, because it sets up a local tunnel. So I'm pretty sure it's for local. So for example, we can say, hey, let's listen on 8888, port 8888. That's going to be here on Mac, okay? So that's the local port. And then in the middle, we put 172.16. And this one will be Kali, which I think was 134. Because Kali's going to be, think of it as like the remote box that we control, okay? And then on, sorry, I already messed that up. We're trying to connect to Ubuntu. So Kali is the remote box. It's 134. That's the one we control. We're trying to connect to 129, which is Ubuntu. It's the one with the web server on it, if you recall. Okay. So now we got that set up, and we'll just say that we're trying to connect on 80. Okay. All right. And then this is my username on Kali. And so anytime you try to connect with SSH, you're always going to say like either -L your username or username @ is kind of the more popular way. So this is just the normal stuff. All right, and I think Kali was at 134. So if I've got all the stars aligned and all the ports right, oh, yep, it's yep, password yep. All right, so. Okay, so I entered my password to unlock the key, this ID RSA. That was the prompt you saw from Mac. And then I entered the password to log into Kali because that's password protected as well, if that makes sense. All right, so now we've made this SSH connection to Kali, and that's all great. But if I open up a browser, and now if we go to localhost, and we said it was 8888, then I can actually get over to Ubuntu. And if we know the path to a web application on there, we can get to that web app. So over here on Kali, what's happened is we've connected it over an SSH tunnel, fully encrypted and protected by this RSA key and the whole 9 yards. Very, very hard to sniff, very, very hard for anyone who's watching the network to detect this traffic. Then this box here, Kali, has connected over to the website that was running on this server. So if we did netstat, and I think oops, I left out a pretty important word, name of the program. So you see how we have these connections coming in, right? But they're coming in from 134. And 134, remember, that was the connection from Kali, not the connection from Mac. We don't even know what Mac's IP is, but we know Kali's on 134. So this kind of tunnel, and then and you can pass. If you noticed, one of the nice things about this tunnel is you can just pass arbitrary input because it's just going over SSH, right? So it doesn't really matter what the traffic is necessarily. And you can also even use the -D option to make a SOCKS proxy if you're into that thing, where you can have basically arbitrary ports on the server side as well. Now here we kind of hard coded the ultimate port, right? Port 80 on the web server. But with the SOCKS proxy, you can actually get away with having not having to name the ports. So lots of good ways to tunnel data back and forth. Obviously, this technique is ambiguous as far as whether this is good or bad. It just depends on what you're doing with it. It's useful in both contexts, and hopefully that helps understand tunneling data a little bit better. Now, if you're trying to tunnel data actually through like outside of a company or inside of a company, these techniques may not work. These are more like intra-company transfers. If you're trying to get out of a firewall, you have to actually work with the firewall in a port that it'll allow. So a lot of times you end up doing this kind of stuff over, like, say, DNS. And there is a Netcat variant written by Ron Bose called DNSCat that does just that. It sends the same traffic, but instead of sending it over a TCP or UDP port, it sends it over DNS. So you can look into that and see if that might be useful as well.
Was the other guy's name Michael Bowman?
I think so, yes. Thank you, Michael Bowman. Right. Yeah, that sounds right. Yeah.
B-O-M-A-N.
One of the problems with running commands with command injection is you end up running one command at a time, and so it limits your ability to actually do useful work on the site. So one of the things you could do is set up a shell. So here we'll set up a Netcat listener. We're going to use -L for listen on -P port 1235. Go ahead and get that listener running. And then we'll go ahead and tell the web server to start up a Netcat on its side and connect back to us. You want to use a reverse connection, generally speaking, because egress filtering on sites is generally less restrictive than the ingress filtering. So we'll go ahead and set up the command injection we've been using, and then what we'll do is we'll set up the Netcat shell. Let's take a closer look at this command. So we'll make this field a little bit bigger. So here we have the separator to start the command injection, and then we're just going to say Netcat back to the IP that we're running on, which is 172.16.05. That's our IP. And then that port that we picked, 1235. The -E option says run this program and connect the input and output of that program back over to the listener, which of course is our machine. So with the listener waiting, go ahead and click the button to send the command over, and then when we go back over here, we'll see that we have the connection, and now we have a basic shell that we can run as many commands as we want to in back to back without having to continue to inject the site.